Hello everyone. Today we will be constructing the perpendicular bisector of a line segment using a ruler and a compass. Well, this is the simplest of all the constructions we have done so far, and we have to only follow few simple basic steps. Before we start the actual construction, I am going to discuss something about perpendicular bisector of a line segment. For that, we are here using the GeoGebra application. We are using GeoGebra Classic here, and just watch what I am trying to say and how this will lead us to our main construction. I'm using the GeoGebra tools here first and drawing a line segment with a given length. I'm choosing here the length of 8 centimeter, and I'll have a line segment AB which is 8 centimeter long. GeoGebra has these tools which we can use, and automatically we can get a perpendicular bisector. So here we are going to find the perpendicular bisector of AB. You can see the G line, which is dividing AB into two parts. This is the perpendicular bisector of AB. We can always check whether it is the perpendicular bisector or not. We can name the point of intersection here as C. We can also give a name to any point here as D. And we can check the measure of angle ACD. We can see this is 90 degree. Also, we can test whether AC is equal to BC. That means it is equally divided or bisected into two equal parts or not. For that, also, we can check the length. AC's length is 4 centimeter and BC's length is also 4 centimeter. So it is proved that we have drawn a perpendicular bisector of line segment AB here. Now, it is very easy here to use this application and to draw a perpendicular bisector. But our goal is to construct it with the compass and ruler. So, we are going to proceed to that part. But what I want you to understand here is a basic property of perpendicular bisector. Now, we already have this point D on the perpendicular bisector. What we are going to do is we are going to join D point with A and D point with B. So you can see we have got a triangle ABD. Can you say something about the side AD and the side BD? We will check the length of the side AD. Here we can see it is 6.42 centimeter, and we are checking the length of the side BD. This is also 6.42 centimeter. That means the two sides of this triangle ABD are equal, or it is an isosceles triangle. And we also know, if you remember, in an isosceles triangle, if a perpendicular is drawn from the apex or the vertex opposite to the unequal side, it will bisect the unequal side or the third side perpendicularly into two equal parts. So we already know it is the perpendicular bisector, and we have also seen that the distance of D from the two end points A and B are equal. Now I want to check with another point. Let me take a point here on the perpendicular bisector as E. And again, in the same way, we are going to join E with A, and we are going to join E with B. And we'll also check the length of AE and BE. It is 4.48, EA is 4.48, and EB is also 4.48. So we have taken another point and we saw it is also at an equal distance from the endpoints. That means on this perpendicular bisector, if we take any point, that point will always be at the same distance or equidistant from the endpoints of the line segment. Did we discuss this? Because we are actually using this property in our construction process. So stay tuned when we check how we are actually going to do that construction.